أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. I would like to welcome you all on the behalf of Aisha Abbasi, the Communication Director of Quest Innovative Study Circle. Today's webinar is hosted by Quest Innovative Study Circle, whose utmost goal is to provide each and every basic tool to the learners regarding the technical learning and the job hunting, which is a quite relatable problem these days. There have always been a need of technology to improve and implement learning, but there was no other platforms where you can actually gather your knowledge about how a job hunting process goes. But now, Quest Innovative Study Circle is trying its best to cover all the aspects of technology and innovation, whereas today's webinar is also a part of Quest Innovative Study Circle's initiative regarding the job hunt of the young engineers, whether they are an automotive engineer or an aerospace engineer. Let's begin with the notion that science can amuse and fascinate us all, but it is engineering that changed the world. Today, I'm thankful to you all to join the extremely important webinar for those aspiring automotive and aerospace engineers who are looking forward to seek a required job in their desired industry. But the only problem is that their aspirants face they do not actually know what industries are requiring from them. To solve this problem, our guest speaker, Mr. Parveen Kumar, who is a mechanical engineer with an immense experience of 15 years, who knows what the technical industries require from the young automotive and aerospace engineers, is going to cater many questions arising in every mind of a young aspirant regarding the industrial requirements of an automotive design engineer and an aerospace engineer. Heading my mic towards our guest speaker with a strong zeal of appreciation, Mr. Parveen Kumar.
Yeah, thank you, Aisha. It's wonderful talking to you, and it's been an honor to be invited to this event. And am I audible? Aisha, am I audible now?
Yes, sir,
Yes,
you are
sir.
audible
Yeah, thank you.
and we
Thanks a
can
lot.
see you.
Yeah, thanks for the confirmation. And again, huge thanks to Mr. Talha and Mr. Mudasir for inviting me to yeah, welcome you all and address your audience. And it's been an honor to talk to the students of the Pakistani community. And here I am yeah, I'm Praveen Kumar and yeah, we'll be starting the session. So I'll be explaining more about my expertise. I'll be explaining more about what the automotive industry is looking for. And at the end, there will be a small session for, yeah, I'll be answering your questions if you have any. So shall we move into the session?
Yes,
Okay.
sir, sure.
Yeah. So today we are going to discuss about what are the industry requirements of an automotive design engineer. So as an automotive design engineer, like before I start, let me introduce myself. I am Praveen Kumar and I have more than 15 years of experience in the automotive industry. I have worked with many companies like Daimler, Mercedes-Benz, Ford, Renault Nissan, Ashok Leyland, General Motors, Mazda, Mustang. While working with Ford, I have worked with Jaguar Land Rover, Mazda, General Motors. So these are the a lot of organizations that I have worked with, and I have worked with almost all the design team across North America, South America, in Europe, more specifically into Germany. Then have supported teams with South Africa and Australia as well. So this is about my experience, and my expertise lies in powertrain, engine design, engine, transmission, body design. So before we begin, so let's first try to understand how to get into the automotive design industry. So when I think most of you are fresh engineers, or either you are already pursuing your mechanical graduation. So you might be either in your second year or third year or final year. So when you pass out of your college, you are a fresh graduate. Okay, so a fresh graduate, either he can get directly employed through campus interviews that will be conducted by your college or university, and then you become a design engineer. Or if, if you're not able to get campus placement, your next option would be to directly, once you graduate, you get the required training on what is expected by the industry. Training in the sense, for example, see, you are like currently doing your mechanical engineering. You have a lot of subjects like strength of materials, design of machine elements, kinematics of materials or machines. So there are a lot of subjects, but whereas the automotive industry, we expect a whole different concept or whole different knowledge. That's the current expectation of any automotive industry. So that's what I'm going to explain. So what is required by a fresh design engineer to know, what is he expected to know, and what is the current syllabus is given in your like in your college graduation. That both are entirely different. So a lot of training is required to understand the expectation of the industry and to get skilled up to that level. And then you move through a reference. For example, if you have any friends or if you have any project managers working in any automotive industry, then you get directly, you referred by them. Then after your reference, you go through the interview, and then finally you become a design engineer. This is how the actual process works. Either you get employed directly through campus interview, or you take the second method. So now the problem is a lot of mechanical engineers, they are already skilled enough. Like, so they what they think is, yeah, I have completed my graduation, so I don't need any new extra knowledge to get employed. So I am a mechanical graduate. So as a mechanical graduate, I can get employed anyway. So that is what the mindset of every candidate who passes out of who graduates. But the fact is, almost 80 percentage of the people in the industry, they're not being employed. The reason again is the skill set what we expect from the automotive industry is entirely different from what we get from the colleges. So this is what that's going to be the main struggle. The main again, why a fresh graduate struggles to get into the industry. First thing is they will be too much confused about what to do. So as a mechanical engineer, few might be interested to get into like for higher education. As a mechanical engineer, few might get into few might plan to get into IT sector. Few might think of starting their own business. Few might think of, okay, I have like few might think of innovating their own product. So there are a lot of confusions, and there are few might who might be interested to get into core sales domain or core marketing domain. Few might be interested in a different government jobs. So they are not sure about. A lot of people are not sure about what to do after completing their mechanical graduation. There are different industries. Okay, you have automotive, you have aerospace, you have medical, you can get into locomotive, you can get into agricultural equipments, you can get into special purpose machineries, you can get into naval, marine, you can get into semiconductor industry. There are a lot of different industries that you can get into. So a lot of mechanical engineers are not sure about which industry to choose. Then there are a lot of people who move into IT, because again the IT sector pays high, and that's main reason that a lot of mechanical engineers, even after doing a core mechanical, they might plan to get into IT. Then a few don't know themselves. Okay, so this is one of the main reason. If you have heard about SWOT, SWOT, SWOT stands for strength, weakness, opportunity, and threat. So a person has to know what he is good at. He has to know what is his strength. He has to know what is his weakness. He has to know what are the opportunities that where he can flourish, and he has to know what are the threats. That what are the weaknesses or what are the areas he has to develop or he has to improve on. So a person, a candidate has always has to do the SWOT analysis before trying to get into the market, get into his or career. Then the next main option, the main reason would be lack of technical skills. As I was saying, a mechanical engineer knows a lot of theory, gains a lot of theoretical knowledge during his bachelor's. So he learns about dynamics of machinery. He learns about the technical topics. But when it comes down to the industry people will always look for okay whether the candidate has good experience on the actual domain. So when I say domain, domain is nothing but the actual. I'm going to explain each and every domain in the automotive industry. A domain is nothing but the actual department. Okay, so the actual component. And next topic would be the lack of communication skill. And again, a lot of people they might have good technical skill, but might not be able to communicate properly. So if you're not able to communicate properly, then the interviewer will think that okay, you don't know the particular skill, so you don't know the basic skills. So as much as learning technical skill is important, communicating that properly with your colleague or with your hiring manager or with your customer is very much important as much as your technical skill. And finally, the reason why a mechanical engineer doesn't get a job is because they fail to prepare for the interview. So you prepare for your examinations, right? So before every examination, you prepare, you sit down, you study for hours for your examination, and then after preparation for your examination, you attend your exam. The same way, if you are planning to get into an interview or if you are planning to succeed in any interview, you need to prepare for that, which a lot of people don't do that. Okay. So, for example, let's say I have two candidates. We have a candidate A and candidate B. So the candidate A has good knowledge on all the different softwares: AutoCAD, SolidWorks, Siemens NX, CATIA V5, ANSYS, Hypermesh. Okay. Whereas I have a candidate B who knows CATIA V5, remastering, A to B conversion, mounting features, DFMEA, manufacturing process, design consideration. So these are the knowledge he has, the candidate B. The problem is the market is filled with 95 percentage of the market, or even I would say 98 percentage of the market is filled with candidate A. Okay, these are
There
the
is a
people.
one question.
Yeah.
Uh,
Yes.
is there any notes you are sharing?
Yeah, I'm sharing the screen. Okay. Are you able to see the screen?
Okay, there is showing the meeting, party meeting. There are no
Oh,
slide.
okay. Just give me a minute. Okay. I'm already sharing the screen now. Are you not able to see the screen?
We are seeing the meeting link, the meeting of CATIA. Okay, get it.
Okay. Can you just confirm me now whether you're able to see my screen now? Are you able to see my screen now?
Now it's visible. It's
Okay. Thank
just
you. Yeah. Thanks for yeah. Thanks for letting me know. I think it's visible now, right? Shall I go ahead? Right. Okay. So there, are you able to see the screen now? Candidate A and candidate B, the one who has knowledge on
yes.
multiple software, right? Yes. Thank you. So, as I was saying, 98 percentage of the market is filled with candidate A because a person, if he wants to become a design engineer, what he does is, yeah, he goes and learns all the design softwares. starting from AutoCAD, SolidWorks, CATIA, NX, Creo, ANSYS, Hypermesh. The problem is, if he's trying to apply for a company, if he's trying to apply to a job in a automotive company, any automotive company will always use only one software. They're not going to use AutoCAD. They're not going to use SolidWorks, everything all together at the same time. Eh, If you are taking Ford, for example, we use only CATIA V5. If you are taking NX, if you are taking Nissan or Daimler, we use NX alone. We don't go for CATIA. And none of the automotive companies use SolidWorks at all. So learning AutoCAD, SolidWorks is not going to help you get into any automotive company because they are not being used anywhere. Automotive industry uses only CATIA V5 or Siemens NX. So which again I'm going to show in the next few slides. What are the different softwares which are used by the different companies? Okay, this is the let's say candidate A. But whereas I have a candidate B who has extensive knowledge on CATIA V5, and apart from learning CATIA V5, he has good knowledge on how to do remastering. Remastering is nothing but creating a parametric solid or parametric surface from a dump solid or surface. Then how to do, if he knows how to do class A to class B conversion in CATIA V5. So these are all like advanced skills in CATIA V5. So for any plastic component design, we use class A, and we have a class B surface and class C surface. So the design process will involve creating the class A surface from your styling surface, then creating your engineering surface, which is called the class B surface, which will be created from the class A surface as a reference. Okay, then finally mounting features creation on a class B engineering surface. Then how to do DFMEA, how to do how to if he has knowledge on manufacturing process, if he has knowledge on design considerations, on material consideration and material selections, GD&T and vehicle milestones. These are the keywords. Whatever you're seeing here are the keywords which are required. So these are the keywords which an industry person or a hiring manager will expect from a design engineer or from a fresher. So instead of learning all the different softwares, he has to focus on one software, and he has to gain expertise on that particular software. See, these until this point, this is for CATIA alone. This is the basic CATIA, and these are the advanced CATIA applications which we have to do using CATIA. And these are the industrial technical domain expertise or domain knowledge that you have to gain. So normally if a candidate has this knowledge, he will be much more selected. So 98% of the industry will be filled by these kind of candidates, and only 2% of market is filled by these candidates, and these candidates will be selected by any automotive company. Right? So going down to the next topic. So before we begin, we have to understand what are the or how an automotive or how a car is being designed. So initially, I'll just go take you through this fast. So initially, the planning phase will be done where design engineer will or where industrial engineer designer will design the or do the planning, or the management team or the different benchmarking team. They will understand what kind of car is needed. After the planning is done, it goes down to the designer who does the concept study, and then concept studies, they will make the clay modeling. After clay modeling, they will go for the vehicle architecture. Vehicle architecture is a stage where a vehicle architecture team will decide where your engine has to come, where your packaging has to come, where your seat has to sit, what should be the height of the car, what should be the how many doors does your car need. So these are the entire packaging of the car will be done by the vehicle architecture team. Then it moves on to the detailed design team. So each part of the car will be designed by a separate team. Okay, for example, transmission will be designed by a transmission team. The engine will be designed by the engine team. The vehicle body will be designed by the exterior team, and there will be an interior team. So the seats will be designed by the seat team. So there are multiple teams in an automotive company. So they will be doing they'll be designing the individual components. So when I say a team will consist of 1,000 to 2,000 people. a basic engine will be designed by 1,000 different people. Okay, so for example, for if you take an engine, there will be a separate person who will be designing the piston of the vehicle. There will be a separate person who will be designing the crankshaft of the vehicle. If you take the body, the underbody will have a separate team. More than 50 people will be working only on the underbody of a car. If you don't know what is an underbody, this is the underbody. The upper body of the car will be designed by a separate team. Then after making the detailed design, it goes to the, see, well, we have designed the component. So now how to make a component? So to make a component, we need a tool. We need a mission. To make a component, for example, if we have a sheet metal and if we have to go for a stamping, if you we need to stamp it, for stamping a sheet metal component, you need to have a machine. Again, even after having a machine to stamp it, you need to have a die or mold. You need to have a die design. Okay, more die and cavity. The same way for making a to mill a component, you need a tool. So tool design or die design will be done by a separate team. After making the die design, it goes to the prototype development where a basic component of a basic prototype will be made, and then a production trial will be done. And after the production trial, it will go for the vehicle testing. For example, we have a crash test here. So the crash test will be done by a separate team. And after the final crash testing is done, if there are any defects or if there are any like problems, then that will be rectified. And finally, after all the rectification is done, the vehicle will go for the production launch, or we call it as SOP, start of production. So this is how an average life cycle of a car looks like. So can you guess like how long does it
Excuse
take?
me, sir. I have a question.
Yes. Yeah.
Uh, uh, Sir, basically, I want to ask that what process digital stepper should do to join the automotive industry?
What process?
A digital stepper.
Digital sculptor. So he has to learn, see, for a digital sculptor, he has to learn different softwares like Alias, Autodesk Alias, or he has to learn ISM surfacing. There are different softwares it is required. And there are different courses called like industrial design courses, which are available all over the world. He has to undergo the courses to understand how to do digital sculpting, right? Okay, and one more thing, if you have any questions, please note down your questions. There will be a separate session at the end of the meeting to understand, like you can ask your questions at the end of the session. Okay, so thank you all. And let me move to the next topic. And a lot of people, again, my next topic would be on understanding what software is required. Okay, so a lot of people we have NX, Creo, ANSYS. There are a lot of different softwares available. So what software is should I learn? That is the question asked by a lot of design engineers. So the automotive industry uses only two softwares, only CATIA V5 and Unigraphics NX. If you take CATIA V5, we have companies like Hyundai, Toyota, Volkswagen, Ford, PSA. PSA is now Stellantis Group. Then Honda, Renault, BMW, Mahindra, Tata, these companies they use CATIA V5, and if you take companies like Nissan, Suzuki, Daimler, Mazda, Fiat, they use NX. So it's equally around 70 to 80% of the companies in the world they use CATIA V5, and almost all German companies use NX, Siemens NX. So if you want to get into automotive design, either you have to learn CATIA V5 or you have to learn NX. You need not learn any other software at all if you want to get into automotive design. Now, coming down to the major departments in an automotive OEM, we have uh, the parts design, the automotive, the R&D design, the component design. The component design is split into different, again, you have body, BAW, you have plastic drums, chassis, engine, powertrain. Okay, powertrain in the sense transmission. Then you have wiring harness and seating. Then you move to your analysis team. So a person working on design, he will not work on analysis. A person working on analysis, he will not work on manufacturing. So focus on only either any one of the domain. You don't need to learn both a design software as well as a CAE software, analysis software, because A single team is not going to, there will be different teams, two different teams working on these two different concepts. If you are working on analysis like using tools like Ansys or Hypermesh, you won't be working on the actual design. You won't be working on the 3D modeling. You won't be working on the new product, the NPD activities. So focus either, you don't have to learn everything, just focus on one particular domain and you can gain your skills on that particular domain. That is very much more important. Okay, now coming down to the different domains, I was saying domain, right? So we are going to see what are the main domains in the industry. So when we start with any automotive company, if you take any automotive car, this is uniform for all the automotive companies in the world. Okay. So for all automotive companies, starting from Ferrari to Lamborghini to Ford to Tata Motors to for Hyundai, any country, any cars, these are going to be the common departments in the industry. First one is body department. The body has both exteriors and interiors. When I say exteriors, the body of the car, the exterior body of the car is made out of sheet metal. And this sheet metal, we call it as body in white. The body in white is nothing but the outer frame of a car, which is made entirely of sheet metal. And the reason for the name body in white is it's made of sheet metal, and before painting, it looks entirely white in color, and that's why it's called body in white. So this is called the body in white frame, and these are the closures. The one which close the body in white is called the closures of a car. Then these are the body in white parts and components. So this is underbody. This is the underbody, body under. This is the main body of the car. This is the upper body. Okay, your side doors, your side panel. Okay, body side. You have cowls. This is your tailgate. Then when you see the closures, these are your closure components. Okay, these are your pillars, your A pillar, your B pillar, and C pillars. So these are the body in white. And there are design considerations required. Okay, so to understand how to get into body in white, you need to know what are the different body in white nomenclatures are there. Okay, so what are the different components that comes under body in white, and then you need to understand what are the design considerations in body in white. For example, if you are going to make a draw, what should be the minimum depth of the draw, what should be the maximum depth of the draw. You can't go beyond the maximum depth and you can't come below the minimum depth. These are basic standards required. Okay, so for example, why do we need a backdraft? Okay, so what is a backdraft? Why do we need a backdraft? Or is backdraft allowable or permissible in the industry? What should be the minimum flange length? Okay, what should be the minimum radius, bend radius? There are basic standards required which are not being taught in the current university syllabus. And even if it is being taught in the university syllabus, different industries will have different standards. Okay, but when it comes down to the automotive industry, there are basic standards, common standards which are used by across all the industries in the world. So you need to understand what are the basic considerations which are being used in the industry. Then coming down to the next thing will be your material selection. So for example, see for as I said, okay, the body of the car is entirely made of sheet metal, correct? But the sheet metal that we are using here will not be the same sheet metal we'll be using here. Then we will be using different sheet metal materials. So what material has to be used where? Though that knowledge is very important. So for example, these red color areas are high impact areas, that is high stress areas. So here in these places, you need to have very strong sheet metal. Whereas the violet color areas, the cowl areas, is where you need the least strength of sheet metal. So you can use a light sheet metal component to reduce the weight of the car. So reducing the weight of the car will reduce the safety of the car, whereas it will increase the performance of the car. But whereas in areas like this, you can't use a light sheet metal because this is where the vehicle it has to absorb the crash. So you have to have very strong sheet metal as well as it has to absorb the impact of any crash. So your material selection is very important. So that's exactly what are the different domains. So I showed you the basics of BAW. Similar way you need to understand what is sheet metal plastic drums. You need to know what are uh, powertrain, what is chassis, what is steering system, what is seating domain, suspension, axle, brakes. There are different, these are the different domains in an automotive industry. So you have to, candidate has to choose any one particular domain. He has to choose any particular one different software, either CATIA V5 or NX, then choose one particular domain and he has to gain all the skills to get employed. Now the question is like, what will he do if he gets employed? Like how to get employed and how to, yeah, how to proceed with his career. So, if he graduates and he gets employed in an automotive car design company, he starts as say GAT or graduate engineer trainee or graduate apprentice trainee. From there, he moves to a design engineer position or a senior engineer. Then, within some 5 to 8 years, with an experience of 5 to 8 years, he moves into a team lead or a associate manager position. Then with after 8 years, he can become a design manager or a design lead. And finally, if he crosses around 12 plus years of experience, he can head his own team. He can lead his own team. He can become a general manager or he can become a VP or a director of design. So this is the career progression in any automotive company. And what is the expectation of a engineer? For example, for an entry level engineer, he has to know very strong CAD skill. When I say CAD skill, learning part design, learning surface design is not enough. So he has to know the application of, for example, if a candidate learns CATIA V5, he has to know the application of CATIA V5 in the automotive industry. When I say the application of CATIA V5, it's either he has to know what is remastering. So remastering, as I was saying, was nothing but creating a parametric solid or surface from a dump surface. So when we design a component, so normally what happens in the industry is we don't design a component right from scratch. We'll always have a benchmark. We'll always have a, for example, let's say we have a company like Hyundai. Hyundai is designing a car. So they don't design the car directly from scratch. So they will always have a benchmarking. Okay, they will always have a previous component. So the previous component or the old component will be 3D scanned. The 3D, when you 3D scan a component, the 3D scanned object will be you'll get it as a step file or STL cloud data. From the cloud data, you have to create a parametric component, or from the step file or IGS file, you'll have to create a parametric component. That's called remastering. So the CAD skill I'm mentioning here is a candidate has to know how to do remastering, how to do class A to class B conversion, how to create mounting features, how to do draft analysis, how to create parting line, okay, and how to create master sections. Or if you have created a master section, how to create components, how to generate your components from the master section which is given to you by your client. So these are the basic requirements, CAD skill. Then he should have the knowledge of the component. So the component knowledge is very important. So when I say component, he has to have good understanding of plastic drums. He has to have good understanding of BAW. Any one domain, any one component is more required. He has to have good knowledge on the material selection. So what material will be used in which component? So these are the basic skills are required. Then he should have good knowledge on manufacturing process. So for example, if you are going to take plastic design, a plastic component can be designed or can be manufactured using different manufacturing process. One can be done using extrusion molding. You can do it in blow molding. You can do in rotational molding. You can do it in thermoforming. Okay, you have vacuum molding. So there are different manufacturing process that are used to create components. So you have to, a candidate has to know what are the different manufacturing process is involved. This is for the entry level. For intermediate and experienced level, you have higher requirements, you have more requirements, which I'm not planning to cover now. Okay, now getting to down to the next topic, how to get into the automotive design industry. As I said, your academic performance is very important. You should have minimum 60 percentage of marks in your 10th, 12th, and your graduation. Then you should have very sound technical knowledge. You should have very good communication skills. You should have a certificate relevant to the job. For example, if you're planning to get into an automotive design engineer as a BAW engineer or as a trims engineer, you should have a valid certification on BAW or valid certification on plastic drums. So your certification will help you prove to the employer that you have the relevant skill required to complete the job. Then your projects or internships relevant to the job. For example, if you're planning to get into automotive design as a BAW engineer, there is no point in creating a bottle or creating a airplane in CATIA V5. Your project or the designs or your portfolio that you have, your design portfolio you have, should have projects relevant to BAW or relevant to plastic drums. That is more important than doing some wild or doing some random projects. It's always recommended to do project relevant to the domain that you're applying to. Then your attitude, when I say attitude or enthusiasm, it's more about how willing you're how willing you are to learn a particular subject. Okay, so if someone is going to teach you something, if your manager is asking you to do a work and if he's teaching you something, you should be willing to learn the new concepts. You should be willing to learn and apply it. So your attitude, learning attitude, your attitude to work or your attitude to go improve continuously is very, very important. And finally, a soft skill, your negotiating skill, your leadership skills. So these are very much important. So I'm just going to show you the different, as I was talking about the plastic drums. So this is what the remastering I was talking about. So this is what I was talking about. This remastering. Okay, the component that you saw was a basic small bracket. Okay, the small bracket, it might look very easy to you. When you do that in part design, it's very easy to be created. But in the industry, we don't use part design. We don't use solid modeling. We will always go with surface modeling. So when you start working with surface modeling, doing the small bracket will itself take minimum 1 to 1.5 hours. The small bracket will take minimum 1 to 1.5 hours. That's why doing complex components will easily take around 4 to 6 months of time. For example, if you're working on a big door or if you're working on a hood design, the hood design or the door design will take easily 6 to 8 months. If you're working 8 hours a day, It will take 6 to 8 months for you to complete the component, entire design. So that's how complex the designs are going to be in the industry. So these are the basic skills which are required by an automotive design engineer and which are being expected by the industry. So next one would be on this is class A to class B conversion. So you can just take a look at this video. So what you see, saw here was actually a cup holder of a car. To create a cup holder of a car, you need to have the outer surface of the car, and then from the outer surface of the car, you make a inner surface called the B surface. And after creating the B surface, we create the mounting features on the B surface. So this is another kind of examination or technical. This will be a second interview question or interview tool test. So when you start applying to an automotive company, this is for your first round of interview will be your technical interview or your tool test, where they might give you either a remastering work or a class A to class B conversion in CATIA V5, and the candidate would have to complete the work within 1 to 1.5 hours maximum. If you are able to clear the first level of interview, you move to the next level, next round of interview, which would be the technical interview on the domain. For example, if you're invited to or if you're applying to a plastic drums, so the questions will be on like what are the different types of plastics, then what are the different plastic manufacturing process, what are the defects in plastic molding, what are the advantages and disadvantages of plastics or metals. So when I say types of plastics, so basically you have two types of plastic. I'm just giving an example here. These will be the questions which will be asked: thermoplastic and thermoset. So what are the basic interview questions? So again, what is the difference between a thermoplastic and thermosetting plastic? Why a thermosetting plastic or why a thermoplastic is better than thermosetting plastic, better than the other? What are the applications? You should be able to understand, you should be able to answer these questions. Okay. Then what are the different manufacturing process in plastics? For example, you have compression molding, transfer molding, injection molding, blow molding, extrusion molding, calendering, thermoforming, laminating, slush molding. So you should know what are the different plastic molding. So how a plastic compression molding is done. Okay, what are the advantages of compression molding? What are the advantages and disadvantages of compression molding? Then what are the applications? So what components in a car is made by using compression molding? Okay. So then a transfer molding. So how a transfer molding is done? What are the applications, advantages, disadvantages of transfer molding? What are the applications? Again, going for injection molding. Injection molding around more than a 70% of the parts in car and any automotive is made using injection molding. Why injection molding is preferred? Why? What are the different stages? What are the advantages? What are the disadvantages? So these are very extensive topics. These are the actual requirement that what we expect from a candidate. So when you start learning, when you are planning to get into automotive, you have to have the knowledge on these different manufacturing process. These are the calendaring. Then you have thermoforming. So what is thermoforming? What are different types of thermoforming? Why is thermoforming used? Okay. So what are the applications of thermoforming? Why can't we use injection molding instead of thermoforming? So these are the questions that will be asked. So right now we just saw two different two questions, but similar to that, you should know what are the defects. So when I say defects, what is a flash? What is flashing? What is warping? What is bubble? What is your short mold? What is sink marks? What are flow marks? What are pin marks? Why do you get pin marks? So for example, if you are getting a sink mark, why do you get a sink mark? How do you troubleshoot a sink mark? How do you make sure that you don't get a sink mark? What are the causes for sink marks? You need to have, as a design engineer, you need to understand where a product will fail and how to avoid the failure. That is very important for a design engineer. Then what are the advantages and disadvantages? What are the materials? What is a slider and lifter? What are undercuts? What are the different grades or what are different gates that we use for in plastic? What are the different plastic grades in plastic? What are the different grades in sheet metal? What are the different design guidelines? When I say design guidelines, for example, if you are going for a boss, what should be the height of the boss? What should be the minimum depth? What should be the thickness of a rib? So if I am going to design a boss, what should be the thickness of a boss? What should I keep as the so for example, if I'm going to make bosses, we should have stiffness on side of the bosses. What should be the minimum thickness of the stiffener? What should be the uh, fillet radius of the boss or the stiffener? There are different guidelines. So these are the stiffness. So what should be the minimum thickness? Then under the boss, what should be the diameter of the boss? If I'm going to go for fillets, what should be the radius, minimum radius? What should be the inner radius, minimum radius of the bend? Okay. If I'm going for a gusset, what is the proper way of gusseting? Okay, so when you make a gusset, you have to ensure that you have chamfer at the four corners. You can't make a sharp corner for a gusset. Draft. These are the design guidelines. So when I say coring, what is a coring? Okay. Gate locations. So ejector pins. Where should you have a ejector pin? What should be the tolerance? What are undercuts? These are undercuts. Why do we need to create an undercut here? What's a metal insert? These are all what are you seeing in on the screen? These are very extensive topics, and it will take minimum 2 to 3 years to explain this. Okay, so these are the basic guidelines that is required for a design engineer. So the point is, to become a design engineer, you need just learning the CAD softwares alone are not enough to become a design engineer. You need to have extensive knowledge on the materials. You need to have extensive knowledge on the design guidelines. You need to have extensive knowledge on the manufacturing process. All these are required to make you a proper design engineer. And this is what an industry will always expect from a fresher. So right now it's like I have completed my presentation. If you have any questions on, or if you have any specific questions to be answered, then I can answer your question now. I hope the session was informative for you.
I got a question, sir.
Yeah, thank you. Please go ahead.
Sir, as a student, I am a student of computer systems engineering of final year. And what process should I get through to join the industry of automotive design?
Okay, so you are from computer science, right?
Yes.
Okay. So as a computer science engineer, see, an automotive industry doesn't employ only mechanical engineers. We have electronics engineers who works on sensors. We have electrical engineers who work on the complete electrical wiring of the car. We have mechatronics engineers who work on the ADAS advanced missions. Similarly, a computer science engineer will always work on the automotive design. For example, if we are working on some machine learning, advanced automotive design, we need people who can do coding on Python. So you can there are a lot of departments in the automotive industry where Python is used. So there are the data science engineers in automotive companies. Yeah.
Actually, I'm talking in a sense of exterior or interior designer, like we can say digital sculptors are working in this field and some other sort of positions. So, is there any position that a computer systems engineering student can join after completing their bachelor's?
See, if you're planning to work on the actual design of the car, then you need to have good knowledge on the mechanical properties and concept of the car. But as a computer science engineer, if you want to still work with automotive company, then these are the data science or these are the field in which you can try to get employed. Because as a computer science engineer, you need to understand the mechanical properties of a car before getting into the mechanical domain.
So, what do you think that how this artificial intelligence, as this thing is going to be powerful day by day, do you think that it's going to take the jobs of automotive design engineer?
Of course not. Be it artificial intelligence or anything, you need always artificial intelligence is not going to replace humans. It's going to help humans in the future. There are going to be a lot of jobs which are going to be obsolete because of artificial intelligence. There are going to be a lot of jobs which will be like, say, for example, making this parametric components from dumb solid. In a few years, there will be like artificial intelligence which will replace it. But there are again a lot of jobs which can't be replaced by automated or artificial intelligence, like taking decisions. So, for example, selecting materials, taking decisions on particular concepts. Of course, we need human intervention there. So learning artificial intelligence is going to help you, support you in making decisions, in making faster decisions. It's not going to replace humans at any point of time. Did I answer your question?
I have another question that what program should I take after completing my bachelor's to join this industry? Like any particular program, is there anything?
Yes. See, for example, we are into we are from the, design houses, so train people on automotive design. For example, if we are a mechanical engineer, we train you on BAW design, plastic drums design, seating design, engine and powertrain design. So different people will have different ambitions, career ambitions. So based on their career ambitions, we can train people on these domains. We can even partner with your universities and give this program on a affordable cost for you. And then, or if you're an electrical electronics engineer, we have programs on electrical wiring harness. We have programs on autonomous vehicles. We have programs on advanced driver assistance system ADAS. We have advanced program and Python programming for automotive engineers, for computer science engineers. We have advanced program on machine learning for automotive engineers. There are different programs that we provide. So as an automotive engineer, if you want to get into automotive design, of course you need to gain skills on this. So if you want a detailed answer, you can always visit me on my LinkedIn profile. I can share you the different programs that we offer, or I can share you the different programs if you want to get into mobility, advanced mobility, or if you want to get into uh, mobility programs. You have a lot of programs in which are conducted in a lot of European organizations. I can guide you to get into these organizations or into these universities.
Thank you for this. Can you please share the slides and the link of your LinkedIn profile to Mr. Mudassir?
Yeah, Mr. Mudassir might already have my LinkedIn profile, but unfortunately, these slides are confidential. This is the property of design houses. So, and this will be shared only to the students. I am just showing you to make you aware of what are the requirements. So if you want to learn it, of course, I can like work with your university. I can collaborate with your university, and we can train all your students on all these topics.
Sounds good.
Yeah. So any more
Yes,
questions?
there is a F18 mechanical 79. You have raised your hand, so you have a question. Any other student wants to ask the question? So, mic is over to you, Aisha.
So I hope the session was informative to all of you. And if you have any questions, of course, feel free to ask me. You can connect with me on LinkedIn, and I'd be able to answer your questions anytime. And thank you, Quest, for conducting the session, and thank you, Mudasir and Talha, for inviting me to address your students, and thank you for Aisha for being such a great host. Thank you.
Thank you so much, sir, for
Thank you
joining
so
us
much.
today.
So, Mudasir or Talha, if we are done, can we wind up the session? Just need a small. I have a small request from the Quest team. Okay, with the organizer. So after the meeting is done, I would like to have a small feedback from the participants. So what they liked about the presentation, and what they wanted to hear more, because this feedback will help me better my presentations, or better my what I'd say, my the way of the approach. So if you have any specific things in your mind, you can always let me know. I'd always require, like, I'd be happy if you can give me a basic feedback from your students. Thank you.
Yes, the students are directed that in our description, the email of sir is given and email of our organization is also given. So for feedback, you can email us, and you can also in Teams can you give feedback. And we are very thankful to our guest speaker, Mr. Praveen Kumar, for giving us such an informative session and his a valuable time. We are very thankful to you, sir.
Yeah, thank you, everyone, and wish you a great weekend. Thank you for spending your time. Have a great day.
Thank you so much, sir. So we are ending the session and all recordings will be provided to students.
Thank you. Thank you, sir.
Thank you, sir. Thank you.